Hello everyone. So today I just want to give you an update on one of my latest projects, which was parallel image. So the first time I showed it to you was just basically simple filters running both CPU and GPU in parallel, and also serial on the CPU. So I worked a lot on that, and I think I actually got to version 1. The code is not perfect, is not the fastest as possible, but is in a good state in which I can leave it because I'm dying to do something else like OpenGL, pure OpenGL stuff. So I wanted to get it in a good state, in a good place, and leave it there for now. Okay, so let me actually show you what I did. So if I actually recompile that really quickly, it's not super quick, the compilation, because there is so much going on. There is Qt file generation on time that those get compiled. There is the pure C++. There is the CUDA, which actually get compiled with the NVIDIA compiler and so on. But you see, it's not too bad. So this is the UI. Now we have a UI where we can do a lot of stuff. But first of all, let's actually open an image. So I'm going to open this battlefield, background. And it's a 9K image, so it's pretty big. But you can see the playback is quite fast. It's actually scapping with the vertical sync of the monitor, so 60 FPS. So the reason why it's like that is because I went all the way to use OpenGL, implement a Qt widget which draw OpenGL, because I didn't want Qt to slow me too much. So I say, okay, let's go all the way to make a pure OpenGL call. So you can see here basically we have two triangles and the textures getting loaded and sampled on the GPU for the drawing. So now we can decide what kind of computation we want. So let's start with CUDA, the GPU. And here we have several filters. So this is actually generated automatically for the filters that are registered in a C++ map. It's not a plugin system, so the map right now is hard-coded, but the only thing I need to do if I want to add other filters is just expand that map and everything should work out the box. So let's start with the Gaussian. So here I added a filter, and let's see what happens if we increase the sigma up to 10. Here we go. So it was quite fast. You need to consider we are running on a 9K image, and for each image we generated a stencil 10 by 10, so we are sampling 100 pixels for each pixel we want to blur, so it's quite big already. And actually let me show you what's going on here. So we can see here the percentage of usage of the GPU. So if we bump that down and we bump it right again, we should see actually I didn't, sorry. There we go. So jumping up to 99, so CUDA is performing the blur, and here we go. Okay, so let's bump it down to a value which is more, I don't know, like 3. There we go. So we added a bit of blur, but we can actually stack filter one on top of each other. So now I'm adding a black and white filter, and is re-evaluating everything on top of each other. So you see now we have both the blur and the black and white. Actually here the UI gets reset and it actually loses the value, but we can bump that up to 5, and you see and the blurs happen. Okay, so we can also do, I don't know, we can do a sharpening on top of that. And here we go. So one thing that I want, but this is basic usage. It's nothing cool, nothing super fancy, basically just a couple of filters, but not because I want to make an image processing software, but just to learn. So one of the big thing I wanted to do was to be able to have this UI dynamically generated, those sub UI, one for the filters, and not them being generated manually by me. So every time I add a filter, I don't want to manually go there and generate the UI. So the way I achieved that was basically creating a series of attributes which actually let me let me learn a bit more about templates and stuff, and basically when I need to generate those sub UI, those filter UI, I just ask to the filter, okay, give me your attributes, and for those attributes I can query if it's a integer, if it's a float, and based on that I can generate on the fly the widget that I need. So in this case, for a float, I decided to have a slider and a spin box connected together. Okay, so for example, black and white don't have anything, just the evaluate button, so nothing gets generated. But if you add, for example, an edge detection, which is not going to work, I think, right now, because for some reason it freaks out quite a bit. No, it works. Kind of hard to see much. I don't remember how I reset the image. I remember there was one. Actually, I don't remember it. I set some shortcut for doing so. I don't remember the shortcut. Actually, let's see. No, I don't want to go dig down in the code. The shortcut. We can just open another image, or reopen that again. There we go. So anyway, this was the idea behind everything. So the code can be optimized heavily a lot. I mean, when I mean a lot, is a lot, because for example, when I'm CUDA, I'm bringing back the image data in order to send them to OpenGL. Of course, I'm transferring 9K, an image of 9K, which is a lot of byte, twice extra, which I don't need because the data is already on the GPU. There are ways to write from CUDA directly to OpenGL buffers. So once it's there, I can just say, okay, draw it. Okay, I don't even need to upload that anymore. But and also, for example, I'm re-evaluating the whole stack rather than, for example, if I evaluate the fifth filter, I don't want to re-evaluate all the four before because they are the same. So I should what I will go to do is basically generate a cache, and if I modify the fifth one, I'm only recomputed from the fifth onward. Okay, so those are all optimization I want to do. Also, when I will recompile that on Windows, because I didn't do in ages, I will also want to test some SLI performance to see how it goes. But enough talking. So basically this is the first version of the tool, and I learned a huge amount about C++. Also thanks to all my colleagues that helped me with that, like Martin helped me basically to translate my descriptor concept for the UI, to generate dynamically the UI, to C++, and David and Francesco are two colleagues which are crazy wizards with C++, helped me a lot in performance, code bit clean and everything. So the code is also on GitHub, you can have a look. Don't cry because it's not production ready, so there probably will be a lot of crap lying around, but at least I warned you. And that's it for today, guys. Bye bye.